Let's go through LeetCode 2953, count complete substrings. For this question, it gives us a string word and an integer k, and count the complete substring or word. So complete, it has a definition is that each character in S occurs exact k times. And also, I say that the difference between two adjacent characters is at most 2. For example, AC, right? So you say that AC, for example, A is 0, C is 2. Then this is good, but AD is not good because A is 0, 3 is 6, D is 3, right? So what are we thinking about? Because there are two conditions. For example, we have this kind of word is that we can do, the first thing is that we iterate those kind of character one by one, right? So if we find two character, for example, CI, and let's say I plus 1, right? If we have C, this kind of the difference is greater than 2, then we can have a separator here, right? So in this case, we divide our word into a small segment. And for example, we have CJ plus 1, if they have difference greater than 2, we have another segment, right? And then we just iterate, for example, L plus L and L plus 1, and have a third segment, fourth segment. So in this case, we can, for each substring, right, we count how many words they satisfy the first condition, right? So for example, we have count 1 and count 2, right? And count 3 and count n. We add them up will be our result, because for the second condition is that our substring, the good string, cannot cross this separator, right? So what we're thinking about is what we are going to do is that we are going to use the second condition that two adjacent character is at most 2 to separate the word into different segments. And for each segment, we are going to count the substrings which meet the first condition. So let's write a code for second condition, right? But array equals word which array. And we are going to int a equals array dot length, and we have result equals to 0, right? And we're going to use an index, which we call last. And what we do is that for int I equals 1, let's have I smaller equal to n, right? Because for the last segment, we also want to calculate I plus plus. So what we will say, if I equals n, or array, you said this mass absolute value, array I minus array I minus 1 greater than 2, right? So we have result add equal to, we have a help function called get count, and we are going to have a char, right? At least I should have char. We should have a k parameter, right? And we need to have the start. The start will be the last, right? And the end will be, because we are going to separate at this I index, so it will be I minus 1, right? And let's have last equals I for the next beginning of the next segment. So return result. So this is so in this case, what we convert this question to a simpler question, that is for this kind of word, right? The substring from start to end. How many substrings in this kind of range that each characters occurs exactly k times, right? So what we need is array int k int start int and bar. So for the to calculate how many substrings in this range that every character occurs exact k times. What we're thinking about is that we know the substring can only have length like a k or 2k or 3k until 26k, right? So at most the maximal length of the substring will be 26k because there are only 26 characters, right? So the length can only be from k to 26k. And also we should have a minimum, right? Because the window should not exceed e minus s plus 1, right? Or we'll say the window, we'll say if this kind of 2 I multiplied by k greater than this length, then break, right? So the window will only be I minus 1 multiplied by k, right? Some kind of those we can iterate it to that kind of size of the window. So what we're thinking about is that we can have the sliding window, right? And the window size can be this kind of range from k to 26k or some kind of in the middle, right? Because there is not condition here. So we iterate the window size. So the maximal possible window size is 26. And we just like a sliding window have fixed size the sliding window, right? So for the fixed size the sliding window, so when there is a character adding to the, for example, we calculate the first window, right? And then we move the index. So then we look at the right edge. If there is some kind of character need to add to our window, we count this kind of right part, right? So if there is some kind of character move outside of this kind of window, we count the left count, we remove it out, right? So so for each window, right, we need to calculate how many characters are good. So what is a good? Is that, for example, one character has a size k. We'll say there is one good, right? So for the window, if it is, for example, ik, so we know the good should be I, right? So so doing the slide window, for every window, we try to see after something moving and something move out, we're trying to just check whether this kind of characters, which are k characters, is equals to k, equals to I, right? I is how many the times of window size. If equals to I, then add to our result. So let's begin to write code for this. And we have start end. Int result equals to 0, right? So what we need is for int I equals to 1. I should small equal to 26. Because there are at most 26 lowercase characters. And also we'll say I multiplied by k should smaller equal to and minus start plus 1, right? I plus plus. So let's have a count, right? Count equals new int 26. So I say in the we'll have a good, right? That is how many characters meet the condition that the appears k times. So then we are going to ask slide window int j equals start j smaller equal to n j plus plus. And what we are so for when moving j, right, we need to add the right characters count, right? So we'll see the right character is array j, right? So we'll say if count cr minus a equals we'll have count cr minus a. Let's increase it by 1, right? Increase by 1. So if this one already equals to k, right? So I say good that which have k character number will increase by 1, right? Of course, if this one equals to k plus 1, means there is one character just move out of the good, then we'll have minus minus. So so when we begin to remove the left edge, left part, right? So that is if our j greater equal to start plus I multiply k. Then we'll have char select, and select equals array j minus I multiply k. So we'll also have if count if this count this, so the left one we are going to remove, right? If this one equals k, that means if we remove, the counts will become k minus 1, right? So we'll put minus minus. If count select minus a, if this one equals k plus 1, right? K plus 1, this one means we increase one character which meets our condition. It has k characters, right? K times. So this is just a classical sliding window code, right? So we'll say only when this kind of window size is greater than greater equal to I multiplied by k, right? Because for this kind of condition, right, it will not satisfy our conditions. And also, actually, we just need to write, right? If good equals to I, right? Then we have result plus plus. We can add the condition if j greater than something, right? J greater than something. But we can add, for example, if j plus 1 greater equal to start plus I multiplied by k, and right. But actually, this condition we don't need, because if the window size is smaller than a multiple by k, the good will not be I, right? If the good character counts equals to I, that means the window size should be I multiplied by k, right? So we just have this condition, it is enough. And in the end, we just return result, right? So this will be the code. -1. +1, not -1, +1. If this one equals 2, so equals to I. For this one, because we also need to remove the left, right? So we have the left minus A minus, right? So I don't know. So 2 equals to 0. I is smaller to n array b r cosine t minus a plus minus. So if this one equals k, good. The thing is that we should have put this one inside, right? Because for every slide window, we need to check, right? So we should put this inside. If we put it outside, that is the only when to finish the iteration, we are going to check, right? That will not be correct. Okay, doing like this, the time complexity will be 26n. 26n. Because 26n, because at most we need to iterate 26 different windows, right? And the space is all in, right? We convert to cherry.